So hello guys, today we are going to solve a really good question that goes by the name longest substring without repeating characters. Longest substring without repeating characters. The question number is 3, and so we'll first start by reading the question. What does the question says? So the question says, given a string S, find the length of the longest substring without repeating characters. Okay. So you are given a string S and you have to find the longest substring that doesn't contain any repeating character. That is, all the characters are unique. All the characters are unique in the sense that if this is the longest substring, then all the characters A, B, C, D are unique here. Like all are different. All are different. Okay, all are different. Okay, but what is a substring? What is a substring? Okay, so substring is a part of string. Suppose this is your string, A B C D. So what is a substring is? Substring can be A just A, then A B, A B C, A B C D, then B, B C, B C D, then C D. So these all can be your substrings, and then D. Okay, and similarly C also. So anything that is contiguous, like AB is contiguous, ABC is contiguous, ABCD is contiguous. So substring is basically a part of string that contains elements, but you can't choose elements by skipping the indexes. You have to take them along. Okay, so ABCD, A and D cannot be a substring as the characters do not occur together. Characters do not occur together in the original string. Don't occur together in original string. Okay, so you just have to find the longest substring without repeating characters. In this case, what is the longest substring? It is ABCD because all characters are different. All characters are different. Okay, so now I have understood the question. What I can do to solve this? So let me first go to the brute force approach. Brute force approach. Okay, so if I take this test case ABC ABC BB, or if I take any other small test case AB ABAC, okay, ABAC. So what can I do is for finding all the substrings of this particular string that is of 4 length, I can basically run two loops. Which will start here. For the first index will start here, and for the second index it will go on from this element to the last element. So the second loop will be running like this, and the first loop would be running like this. Okay, first loop would be running like this. So what can be the first, if I delete this, what can be my first loop, what can be my first substring if I try to iterate? So if I fix my I pointer on this variable a first 0 index, and if I try to increment, the values of the j pointer, so if my j value is 0, my substring is a. Okay. If my j value is 1, my substring becomes ab. If my j value is 2, my substrings become aba. Okay, I'm not considering the scenario that you have to look for the ones that contains distinct elements. I'm just telling you how to get the substring first. Okay, how to get the substrings first, because finding the substring with a distinct element is the second choice. It's the second constraint that is given to the problem. Okay, first constraint is finding all the pairs, finding all the substrings. So we can basically run a loop from this to this to this to this to this, and the first substring can be like AB, ABA, and then ABAC. This would be in the first pass when my I pointer is at 0 index and j pointer is running from 0 to n minus 1. N is the size of the array. What about the second pass? Second pass when my I is equal to 1. So it can be B, BA, BAC, because I will start here, I will point here, J will start from here, so it will be BA, BS, BA and BAC. What about the third pass? I starts from the second index, that is I is pointing here. My answer substrings can be A and AC. I equal to 3, that is the fourth pass. Fourth pass, what my substrings can be? Only C. Only C. So what are the substrings that I have obtained? What are the substrings that I have obtained? A, AB, ABA, ABAC, B, BA, BAC, AAC, and then C. Okay. So these are the substrings that I have obtained. So I have broken down the problem into two parts. First is finding the substrings, and then having the constraint. That is given to us. That is, the string should not contain repetitive elements. The element should be unique. So when I have found all of these substrings, what I can simply do is for each of these substrings, for traversal, I can declare an unordered map for all of these substrings, right? That will store the frequencies of all the characters in each of these substrings. What do I mean by that? In this, if I considered a map, A is gonna be one time. In this, I consider a map, A is gonna be one time, B is gonna be one time. If I consider this as a map, A is gonna be two times, B is gonna be one time. I consider a map here, A is gonna be two times, B is gonna be one time, C is gonna be one time. Okay. If I consider here, B is gonna be one time, B is gonna be one time, A is gonna be one time, B one time, A one time, and C one time. A is gonna be one time. For this, A and C, A is gonna be one time, C is gonna be one time, and for C, C is gonna be one time. Okay, so I can, after making all these maps, or while making all these maps, I can check if any character has a frequency of 2, in these maps greater than 1, basically greater than 1 or greater than equal to 2. Okay, so any character frequency in the whole string becomes greater than equal to 2. This means that the string contains duplicate elements. And if the string contains duplicate elements like this, and this, so these two strings will be eliminated. This will be eliminated. Okay. All the other strings, as you can see, are valid. Okay. See, all the other strings are valid, right? A is valid, AB is valid, B valid, BA valid, BAC valid, A valid, AC valid, and C valid. Okay. So these are the valid strings that I get. Okay, fine. Now what about getting the maximum length of all of these? I can simply compare the sizes of all these maps, and those contain the maximum number of elements. That I can store. that I can store as return as my answer. Suppose return mx. Okay, so this can be my answer, because if I consider that ABCD is my ABCD is my one string and ABAAA is my second string. This is of 5 length and this is of 4 length. Okay, so what is my map gonna look like for this? A1, B1, C1 and D1. So what is my map size? 4. Okay, and for this map size is gonna be like A3 and A4 and B1. So what is my map size gonna be? 2. So for all the distinct elements, my map size is definitely gonna be larger, definitely gonna be larger. So I am gonna store this map size into my variable mx and I'll simply return it. I'll simply return it. This way I would get the string, I would get the string with the minimum number of repetitive elements or the maximum number of distinct elements. Okay, so what I said is, if I try to summarize, I have broken down the problem into two parts. First is finding substrings, then is with finding those with distinct elements. And third, what is my third? Okay, then I'll find those with this. I can find. How I can find? By using the method, two loops method. And how I can find this? I can simply make a map. To store all the elements. I can simply make a map to store all these elements, and whichever map has any character that has frequency greater than equal to 2, I'll simply eliminate that string. Because if a frequency is greater than equal to 2, that means the character occurs more than one time. Because if in this string my a frequency is 2, that means my a occurs more than one time. So there are repetitive elements in that substring. Okay, what will I do after I get this string? After I get all the string that contains distinct elements, I'll compare the size of maps of all, and I'll return the maximum map size. Okay, I'll return the maximum map size. Okay, so this is how you can explain it to an interviewer, but the interviewer will not be happy with this, so I'll ask you to optimize this. So what can be my optimal approach? Okay, if I take the same test case what I took here, A, B, A, C. Okay, if I take the same test case A, B, A, C, what I say that okay, if I use two pointers, okay, in this array, if I use two pointers to mark my starting substring, and my ending pointer, it denotes the end of the substring. Okay, my starting pointer denotes the start of substring, and my ending pointer denotes the end of the substring. Okay, so if my starting and ending pointer are initially here, okay, if my string is like this, A, B, A, C, and my starting pointer is here, my ending pointer is here, what I can do is Yes. What I can do is I can I can say that as I have to find the substrings, I have to find the substrings with distinct elements. A correction, longest substrings without with distinct elements. Okay. So what I can do is I can simply make a map. I can simply make a map. Okay, that will consist of character and the particular frequency. Character and the frequency of that character. Character and the frequency of that character. Okay, and what I'll try to do is I'll simply increment the frequency. I'll simply increment the frequency of that particular character that my ending pointer is pointing to. That my ending pointer is pointing to. Suppose A, B, A, C is my string. Okay. This is this denotes that my starting and ending pointer position. My starting pointer is pointing here, my ending pointer is also pointing here. And this is my map. This is my map. Okay. So what I can do is I could simply start from the starting. I can simply start from the starting, and and if I get distinct elements, if I get distinct element that is not if I get distinct elements that is not in my string, that is inside my this box, that is inside my range between the starting and the ending pointer, then I could simply increment this. I can simply increment this. Why? Why? See, see. Consider that this box is my answer. This box is my substring. That is my answer. That is my answer. And how is this my answer? Suppose if there are all the repetitive elements, suppose if it contains all the A's, no matter what, if there is only one element, the first element can be my answer for sure in every case, because this single element won't be repeating for any string, won't be repeating. So this can be my answer solely. This can be my answer solely. Okay. This was my string A, B, A, C. Okay. Now what I'll try to do is when I am on the first letter, I'll increment. Suppose this red box is my answer. Just suppose this red box is my answer. Okay. I'm supposing that the first character is my answer for now. I'm supposing that this box is my answer for now. And what is the condition for the substring? That it shouldn't contain repetitive elements. It shouldn't contain repetitive elements. So 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 if if the character that is in my box, if I have considered this character in my box, I'll simply try to increment the frequency of that character in my map. Okay, I'll simply store the character in my map. Okay, I'll simply store the character in my map. That just says that that this is the character that is currently in my red box. This is the character that is currently in my red box. So for now, and I'll make a variable mx that will store the length of the longest string. So for now, what is the length of the longest string? 1, because this is the character that could be the answer for me. Okay. So what I can do is, if 1 is my answer, like this A is my answer for now. What I'll try to do is I'll simply try to include more elements. But the condition is that those elements should not be repeating. That element should not be in the box before. Okay. So when I'll try to increment this box, when I'll try to include this b, my e pointer would be pointing here. Okay, so when my e pointer would be pointing at this place, I'll simply ask my map. Because I can't traverse back, right? I can't traverse back because it would make the time complexity very high. Because each time you add a character, you traverse back and forth to see if this character is in the string. Okay, so the optimal way is to store all the elements that are inside the box in a map. Okay, so when my box extends, I'll simply ask the map if this character is in my map. So as I can see in my map, there is no b. So I could simply increase its frequency. Right? Okay. If I can increase my frequency, my maximum length of the string would be 2. Okay, okay, okay. So when I saw that if I included 2 elements, my string value is increased, my maximum length string value is increased, I will be more greedy. I will be more greedy. I'll try to increase the size again. I'll try to increase the size again. I'll try to include the other element also. I try to include the third element. Now my ending pointer points here. When I have included an element, I'll first check whether this element is not in my current string, whether it is not in my map, not present in my map. Okay, so I'll ask the map. So this will ask the map. Okay, that if this is on my map, I can see that A is present in my map. A is present in my map. Okay, so what I'll do is if I am moving forward, as the string needs to be continuous, okay, I will try to reduce. Reduce this frequency. I'll try to reduce the previous element that is occurring in my string. Okay, I'll try to remove it. So I'll increase my starting pointer. Till a point comes that my age frequency becomes zero. Or the element that is coming at this place, till that the previous frequency becomes zero. Okay, so till then my starting pointer is increased. So my starting pointer makes this value as 0. Okay, a equal to 0. So now what my string contains? It contains a and b, but the frequency of a is 0. Okay, so now my max size is 2 only, because as I reduced this size, so I don't need to update my mx. Okay, what I'll try to do in the next step, I will be more greedy now, because now my map doesn't contain any recurring elements. I'll try to increase the size again. My end pointer would be pointing here. So when my end pointer is pointing here, I'll just check with my map whether whether it contains the particular element. No, no, it doesn't contain any particular element. But what if it contains and it has a frequency of 0? Okay, so if I just check that whether it contains or not, so my answer could be wrong. So I have to check whether it contains the element as well as is the frequency greater than equal to 1. Is the frequency greater than equal to 1? Okay, so I can, for this case I can see that my map doesn't contain C, so I'll mark C with 1 and I'll increment my max value to 3. I'll increment my max value to 3 because I can see that this contains 3 elements. Okay, so how to get the size? How to get the size of the element? If I try to mark the indexes 0, 1 to 3, so E minus S plus 1, E minus S plus 1 would give me the size. Because why not? Why plus 1? Because as you can see, we are following zero based indexing. So when you will try to minus 3 minus 1, it becomes 2. But 2 is not the size of my array. It is 3. So 2 plus 1 equal to 3. 2 plus 1 equal to 3. Okay. So this I have done. Okay. If I try to do any more test case like BBBB, if all the characters are same. Okay. And this concept is basically known as sliding window concept. Okay, sliding window concept. If this is my answer, my starting and ending pointer is here. This is my map. Okay. For the first element, I'll just check whether the element is present in my map. The map says no, so my element is stored in the map. Okay, my element is stored in the map. Okay, so I'll try to increase. I will be more greedy. Oh ho, but as I become more greedy, I have accidentally pointed to the B element. I check it in the map. I see that it is pointing to it is there and its frequency is greater than equal to 1. So my frequency count would be reduced to 0. Okay, would be reduced to 0 when, because I'll try to reduce the previous occurrence till the element becomes out of my box, you guys see by visualizing, right? I'm trying to visualize. I'm trying to make you visualize. Okay, visualize this stuff because now my B is out of the bound. So my starting and the ending pointer are both pointing here. Okay, now when my B contains 0, so I'll try to increment this again. I encounter a similar situation, so I'll try to avoid this. I'll try to decrement this. Okay, starting and ending position both are here. Okay, I'll again try to increment it. Frequency becomes 1. It again checks for the element. It again sees that it is already present, so I'll try to reduce it again. So what my mx contains, what my maximum length value contains, it is 1. Why? Because every time it is extended by only 1. The box contains only one element, one valid element. The element is not validated because if it is found in the map, and hence it is not validated to become a part of the string that contains distinct elements. Okay, if I consider this test case PWWKEW, WWKEW, if I consider this as my first answer, suppose the starting and the ending point are here only, and this is my map. Okay, starting pointer is here, ending pointer is here. I'll try to increment my ending pointer. My ending pointer comes here. It checks. Okay, so and for the first element, I marked it 1. I marked the frequency as 1. It first checked whether the map contains W. No, the map doesn't contain W. So I'll store it in the map. And I'll increment my box. I'll increment my window. Okay. And what is my mx size? As I can see, my mx is E minus S plus 1. So it becomes 0, 1, 1 minus 1 plus 1. Okay, so it becomes 1 only. It becomes 2. Okay, 1 minus 0 plus 1. 1 minus 0 plus 1, it becomes 2. Okay, so my mx size is 2 right now. I'll increment the e value again, e pointer again. My e pointer comes here. My e pointer comes here. It again check whether it is present in the map. Yes, it is present in the map. It becomes 0, and I'll increment this box. I'll increment this box first, and what the box will try to do is it will try to decrement this value. It will try to decrement this value from 0 to 1. For decrementing the value from 0 to 1, what it will try to do is it will increment the value of start pointer till it is reached at a point that w becomes out of the box. W becomes out of the box. So as you can see that p also becomes out of the box. P also becomes out of the box. So as you are increasing the starting pointer value, you have to decrease this frequency also. You have to decrease all the frequencies that are coming along your way. Okay. Just a second. So so this is also now not a part of the string, so it will also become 0. So the window will be decrementing all the frequencies that are coming out of the box, and till when the start pointer would increase, till it encounters a point that the s end equal to s of start. When this condition is met, when w is equal to w, then it will decrement this frequency also and it would increase. So starting pointer would also come here. Okay, starting pointer would also come here. Okay, so now I see what about my window. I'll just try to increment it again. Implement it again. Does my map contains w? No, my map doesn't contain w. Sorry, k. So my map now contains k. I have stored it in the map. Okay. Now I'll try to increment this value again. My map contains e also. It doesn't contain e, so my e will be incremented. My mx now contains as my e value is here, my end pointer value is here. Okay, so end minus start, because 0, 1, 2, 3. So 3 minus 1 plus 1 is equal to 3. Okay, so my mx has a value of 3. Mx has a value of 3 as of now. Okay, when I try to increment it again, I see that w is already in my map. W is already in my map. This has become 1 because we have included this number also, this character also. W is already in my map, so I'll increment my starting pointer till this W becomes out of my window. So I'll increment this window. I'll try to increment. Okay, so this is my ending condition. Till my end pointer reaches the end. This is my ending condition, and I'll still check whether my mx will be updated. No, it will not be updated because e minus s plus 1 is still equal to 3. So this is my final answer. If I try to summarize what I am doing, what I'm making a window, dynamic window, and I am incrementing its size. I am incrementing its size till there are distinct elements. If there are distinct elements, I'll just increment my end pointer and I'll mark it in my map. Okay. If I encounter with any repetitive element that is already in my string, I'll increment my start pointer. Till a point comes that the character is now out of the string. Now the character is now out of the string. Okay, now the character is out of the string. Okay, so I have to go till there. If I try to write the code for this, I will need an unordered map. I'll need an unordered map as I said, and the map should contain the character as well as frequencies. I'll need a mx equal to 0, that is my maximum size. I'll need a start pointer which will be start and ending pointer which will be pointing at the 0th index for start. What is my ending condition? My ending condition is that end should be less than string length. Okay, and now if what I have to see, first I have to see if my map contains s of n. That means if my map contains the last element that is to be included, if my map contains this value, if my map contains this value and that value is greater than 0, that value is greater than 0, so what I'll do is I'll simply increment my start pointer. I'll simply increment my start pointer and I'll make the frequencies lower. I'll make the frequencies lower of all these elements. Make the frequency lower of all these elements. So I will make the frequencies lower of all the elements that are coming, and I have to do this till a point comes where like a w a b a. Okay, so if this is my string, I have to exclude the previous occurrence from my string. So I'll increment my start pointer till, if c is also included, I'll increment my start pointer till this value comes, and for this value also I have to decrement. The frequency. So that is why I am doing an extra MPP of start minus. So I'll try to run this code and okay. So it has successfully run. I'll try to submit. So it has been submitted successfully. Okay. So if I try to summarize what I did, I have simply made a window. That is increasing its size, as it has any distinct element, as it encounters any distinct element, and it is decreasing its size when it encounters a repetitive element. Okay, repetitive element. So this was it. And what is my time complexity of this code? It is somewhere around, like, I am traversing the whole I'll traversing the whole string, and I'm traversing it 2 times because my starting pointer and ending pointer both are traversing. O of n plus n. Okay, and what is my space complexity? O of n, because we are using unordered map for this case. Okay, unordered map for this case. So this is my answer of this solution. Okay, this is my solution for this code, this question. So if you like the solution, if you have any doubt regarding the solution, you can just ping it down in the comments. And if you have any doubts, anything regarding any suggestions, you can just simply ping down. And if you like the solution, do share, like, subscribe. Okay, thank you. Have a nice day. Bye bye.